different ways of polarization. Okay, this is what I just explained. This is okay, this is what I explained. Okay, if it is an atom, okay, polarization is taking place because of the motion of the electrons. That means electrons are moving away. Okay, okay, this is the direction of the applied electric field. Please understand that this is the direction of the applied field. Okay, the arrow mark over here. And okay, here all these diagrams are when there is no electric field, and all these right side diagrams are when there is some applied electric field, when there is some applied electric field. Okay, now this should not be oval, this should be okay circular, so please consider it so. Okay, so negative charge center and the positive charge center are at the same point. When you applied electric field, okay, so the negative charges move to one side and positive charge to move to other side, because of which there is some dipole moment. Now in this case, okay, which charges, okay, which charges displaced themselves? Which charges displaced themselves?
Positive and negative.
Positive and negative. Okay, where do you have positive charges?
In the middle, in the nucleus.
In the nucleus. Okay. Now, can you please compare the mass of the nucleus to the charge of the, okay, I mean negative charges? Do you know that or not? We know, we all know. Proton mass is almost all. How many times of electron mass? 1830 times. That means 1830 times, okay, proton is more massive than electrons. Am I clear?
Yes, sir.
Good. Now what do I do is, okay, I have a bicycle and I have a car. Okay, both of them are standing on their tires. Okay, not stand. Okay, no brakes and all. Okay, they are standing on star. Sir, how can a cycle stand on a star? Okay, on its wheels. Okay, let me suppose that it has got okay, two side wheels. Okay, which kids use, right? Okay, it is standing. Now I'll apply same force on both of them. That is cycle and car. Which will get displaced more? 5.
Cycle.
Oh,
Cycle.
yes or no? Why?
Yes, sir.
It has
Because
less mass compared to
That's it.
yes,
Less mass,
less
more displacement. Less mass,
more.
more. Right. So in case of an atom, also, okay, will it be the negative charges that will be displaced more or the positive charges that will be displaced more?
Negative charge.
negative charge.
Okay. Right. So in comparison of the displacement of the negative charges, the displacement of the positive charges is very, very small. Okay. So that is the reason we call this kind of polarization as electronic polarization. What do you call? What do you
Electronic
call?
polarization.
Electronic polarization. Electronic polarization. Okay, that is electron IC, because of electrons. Polarization because of electron displacement in atoms is what you call it as electronic polarization. Electronic polarization. Okay. Now, the next figure that you show is ions. Okay, on the left hand side, you see that we have ions. Let me suppose that I'm talking about an NaCl crystal. When I have NaCl crystal, this positive is Na plus and this is Cl minus, again Na plus, again Cl minus, it will extend. Okay, you have Cl minus and Na plus and Cl minus again, okay, Na plus and so on, it will extend. Okay, but I'm just taking one particular combination where we have okay, equal number of atoms and okay, total charge is also neutral. Okay, in this particular arrangement, okay, the negative charge center is over. Okay, negative charge center is
Sir, you're not audible. Sir, mute.
okay, right. Now, am I audible now?
Yes, sir.
Yes, sir.
Okay,
Yes,
right. So,
sir.
okay, these two positive charge centers and the negative charge center are at the same point, and similarly for the lower ionic molecule also. because of which this is not a dipole and this is not a dipole. So when there is no applied electric field, when there is no applied electric field, in these two cases, this dipole moment of these molecules is zero. Okay. Now I'll apply some electric field. Now I'll apply some electric field. When I apply some electric field, the negative charge moves downwards and the positive charge moves upwards. These negative charges move downwards and the positive charges move upwards. Now because of this, there is some dipole moment now. There is some dipole moment. Am I clear? Yes or no? Am I clear? Yes or no? Amma, am I clear? Is there okay?
Yes, sir.
Okay. Now from the right side figure, from the right side figure, how to determine the position of the positive charge centers and how to determine the position of the negative charge centers? 5 seconds. 5, 4, 3, 2, 1. Any answer? Okay.
Positive charges are towards.
In this figure, how do you say that negative charge centers and positive charge centers are separated and they have some different distance between them? How can you say, at least theoretical?
Because
5. Yeah, because what?
dipole.
Oh yeah, I mean they have become dipoles, but how to prove that? Okay, this non-polar combination of atoms has become polar combination. How to say? Okay, how to say?
Let
Okay, when you
electric
say
field
polar,
becomes
no, electric field is there, but in the electric field, I want the positive charge center and negative charge center to be separate. Okay, only when they are separate, you will have dipole moment. Okay, I say that this got polarized. These ions got polarized because of the applied electric field. Now, how to prove that negative charge center and positive charge center are separate? 5, 4, 3, 2, 1. Hint, triangle. Hint, triangle. Okay. Now you got 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3,
let
2,
electric field,
1.
sir.
0. Yeah, electric field is there, but I want to say that the positive charge centers and negative charge centers in this particular diagram are different. How to say that? Because you got 3 positive charges and 3 negative charges. How to get there? How to prove that the positive charge center is different and negative charge center is different? They are at different positions. 5,
Vector
4,
some
3, 2, 1, 0. Nothing. Okay,
would
because you
be
have 3 negative charges forming a triangle. Then the negative charge center will be at the center of that particular triangle, at the center of the triangle of negative charges. Similarly, positive charges are also forming a triangle, and the positive charge center will be at the center of that particular triangle. Okay, so these two triangles have their centers at two different positions. So you can say that the positive charge center and the negative charge center after applying the electric field is different. So this is getting polarized. This is getting polarized. Okay. Now what are moving here? What are displacing here?
charges, negative.
Charges. That means ions. Ions are displacing. So what do you call this kind of polarization? 5 seconds. 5, 4, 3, 2, 1. What do you call it? Yama?
Ionic.
That's it.
Ion
This is
displacement.
electronic polarization and this is ionic
Ionic.
polarization. Am I clear?
Yes,
Right.
sir, but I didn't
Ah.
understand the triangle thing, like how triangle thing and the
Acha, okay. I'll draw the triangle. Okay. Okay, which will help you
I
to
understand
understand.
how
Okay.
the triangle forms, sir. like negative.
Okay. Okay. Control C, Control V. Okay. And then here. Okay. And then this here. Okay. Control C, Control V. Okay. Right. Okay. Now, do you see something there? The blue lines are connecting the three negative charges, right?
Yes, sir.
Okay, yeah, in intermediate you have done many problems with regards to what is the net electric field because of the four charges placed at the four corners of a square, something like that. Did you or not?
Yes, sir.
Yes,
So
sir.
this is same. This is same. Okay, I'm placing the three charges at three corners of a triangle. Now, where will be the net resultant charge? At the center of the triangle.
Yes, sir. Understood.
Understood? So you can say that, okay, the negative charge center is somewhere over here, and similarly the positive charge center will be somewhere over here. So negative charge center and the positive charge center are differing, okay, are at two different places, right?
Yes, sir.
Okay, that's it. Oh, sorry, to this place. Okay, is that understood?
Yes, sir.
Okay. So this is how you will have a positive charge center over here and negative charge center over here. So the positive charge centers and negative charge centers are separated because of the applied electric field, and that's why you call it as, okay, ionic polarization. This is polarization taking place and ionic polarization. Am I clear? Right. Okay, hopefully. Now what do you see over here? What do you see over here? Okay, in this particular part.
I, ions.
Ah,
Same.
yeah, what do you see? Some molecules which are already polar.
Structures of molecules.
Right. Okay. If you take this case, if you take this above case, that is ionic molecules, in this case, the dipole moment of each of this independently zero. So whether you take the first case, that is atomic polarization, or to say electronic polarization, independent atoms were neutral. Here also the ions, okay, let me say this combination of ions is actually giving you neutral situation. Okay, is giving you a neutral situation. So if you come to this particular case, okay, a each molecule is not a neutral molecule. It's a polar molecule.